Scale drawing. Scale drawing is when plans are drawn at a specific ratio relative to the actual size of the object. Why we use it is it allows the drafter to create a drawing which is proportionately the same as the artifact it represents. So basically, because an architect cannot draw a life-size picture of a real building, they have to scale it down so that you can hold it in your hands and look at the plans, but they need to be proportionate to the real thing. So if it has 50 windows on the front of it, then your picture that's the smaller scaled down version should also have 50 windows, not just 2 gigantic windows, assuming they would get the idea. So sometimes we're going to scale from a large object down to a small, but sometimes we go from small to large. For example, if we had a plant cell, we can't see that with our eye. We have to use a microscope, so we have to scale that up to draw a picture to put in a textbook or to put on a slideshow. What we're going to be looking at in class is more along the lines of, let's say that I want a basketball court in my backyard, and it's going to be 12 feet by 4 feet, not regulation, but still large. But the person who's going to put it in my backyard cannot draw a life-size example. So they're going to scale it down, and what you're going to have to figure out is X, the missing information. First, I'm going to label. I'm going to use this as my length. So I have to also label my length on the same left-hand side as my smaller picture. I'm going to label the bottom width, and I'm going to label the same on my smaller picture. I also recognize that this is large picture, this is small picture, so I should see that my numbers go from large to small. I'm going to set it up as a proportion. I'm going to always label. I'm looking at my length and width. I'm going to set up my proportion, and this is going to be my large and small. So for my large, my length is 12, width is 4. I got the 12 for my length for my large, the 4 for my width from my large. Now I'm moving to the small figure. Length is X, we don't know, that's what we have to find out. Width is 1. We're going to use our regular strategies for proportions, which is find a scale factor. If I go from 4 to 1, that's times 1/4. Whatever I do to the bottom, I do to the top. 12 times 1/4 is 3, so X equals 3. Now for me to check that information, I can actually put the 3 in. If I say this X is 3, I should be able to check. Cross multiply. 4 times 3 is 12. 12 times 1 is 12. They are equal. It checks. Okay, let's look at triangles. This time I'm going to make a small triangle and a large triangle. And we will do 3 inches by 4 inches and 9 inches by, we don't know. I'm going to label my length on both, my width on both, recognize which one is small and large, so this time my numbers should go from small to big. I'm going to label, and this time I'm just going to use an L since you know what that now stands for, and a W. and set up my proportions. And we're going from small to large. So for length on my small, I have 3. My width is 4. My large length is 9. My large width is my unknown. Now on this one, I do have a scale factor, but sometimes you're not going to, so I want to show you what you do in the event that you do not. If you do not have a scale factor, we will need to go back to our strategy for finding if the ratios are proportional, which is cross multiply and divide. So I'm going to cross multiply, do exactly what it sounds like. 4 times 9 equals 3 times x. That's cross multiply. 4 times 9 is 36. 3 times x, I can just rewrite it as 3x. I need to isolate my variable, which means my x needs to be by itself. How do I do that? I'm going to divide the 3 and get it out of there. And whatever I do to the right, I do to the left. So this eliminates the 3, and I'm left with x. Divide. 36 divided by 3 is 12. I'm going to make sure that my answer works. I'm going to say, if I'm saying x is 12, I'm going to put it in here. 3 times 12 is 36. 9 times 4 is 36. They are equal. Okay, so those are your notes for scale drawing. Then we moved on to some practice problems. Okay, try number 1 on your own. Pause the video, come back and check with me. Okay, so you should have tried this on your own. We are going to find the length of the second rectangle. So we can say this is the length. We'll say this is height. So I'll set it up as length, height, and set up my proportion. I also need to recognize that this is my large, this is my small. So this is my large, this is my small. Large length is 12, large height is 8. Small length is x, that's what we're looking for. Small height is 4. Scale factor. What do I do to 8 to get 4? It's times 1/2. 12 times 1/2, or really in your head you're thinking divided by 2. So 12 divided by 2, x equals 6. Let's verify. Put your 6 in place of your x. 6 times 8 is 48. 12 times 4 is 48. It checks. Your answer is correct. Okay, try the next one on your own. Pause the video, come back and check with me. Okay, so on the next one, we're looking at a 16-foot flagpole that casts a shadow of 12 feet. So here they give us a picture. At the same time of day, how long of a shadow would a 4-foot pole cast? So we can see that we're going to go from large to small. I'm going to call this height, so I need to call this one height. I'll do length down here, and then so this one's going to be length. So let me set up and label height to length, large to small, so my numbers should get smaller. Height on large is 16, length is 12. Small height is 4, length is x, because that's what we're looking for. You should find a scale factor. What do you do to 16 to get 4? You would really divide by 4, which means you're going to multiply by 1/4. So you're going to do the same to the bottom. And we know that x is 3, but let's make sure. 3 times 16 48, 4 times 12, 48. They do match, which means 3 is our answer. With number 3, because they only give you one picture, go ahead and draw your second picture, then follow the steps before. Go ahead and try that one on your own. Come back and check with me. Okay, so this one gives you information for a smaller podium, but they don't draw it for you. So the first thing we're going to do is draw it. And it says it's 25 to 5. These are inches. So we're going to call this, I'll call this height and width. We're going from large to small. So we're going from height to width. Set up your proportion, going from large to small. Height of the large to width, we don't know. Height of the small to width. Scale factor. 5 to 25, you would divide by 2, so I'm going to multiply by 1/2. So times 1/2, what times 1/2 would be 5? X is 10. Let's verify. Put your 10 in there. 10 times 25 is 250. 50 times 5, 250. It checks.